Hello and Namaste. In continuation with the linear programming problems and after the detailed discussion on the methods of penalties or big M method, we are going ahead with the different kind of problems in this particular session. I'll be introducing with the one question on how to deal with the big M method and when to go ahead with the big M method. Now the question is minimize z is 5x1 plus 3x2 subject to the constraint 2x1 plus 4x2 is less than or equals to 12. 2x1 plus 2x2 is equals to 10 and 5x1 plus 2x2 is greater than or equals to 10. Now in this particular question I have purposely taken a combination of less than or equals to constraint, equality constraint and the greater than or equals to constraint so that I can explain you everything about the big M method in the one question itself. Now if you go ahead with the standard form of the LPP as we have already seen from the previous simplex method, please do follow the simplex method from the I button and go for the simplex method algorithm or a flowchart as well as the minimization and a maximization question. For this particular session, you please go through the minimization, simplex of minimization type. Because whenever we have got a minimization question, we are always trying to convert or we are converting it to the maximization type by. So that means minimize z is equals to minus of maximization, which is minus of z. So we are just making the negative of the objective function given to us. So which is minus 5x1 minus 3x1 plus. Now in the first constraint, in the first constraint we have got a less than or equals to constraint. Now in this case, in the first constraint, if you will observe, we have got a less than or equals to, and because of that we have to introduce here the slack variable. So we have to introduce slack variable in the first constraint because of the less than or equals to constraint. Now as soon as we are introducing this S1, we have to introduce it in the objective function with 0 as the coefficient of S1 as a slack variable. Looking at the second constraint, we have got this constraint as equality. So we did not have to add or subtract the surplus or a slack variable here in the case second constraint, but as we are seeking here for the answer for the LPP, we have to add here the artificial variable to reach to the initial basic feasible solution. So that is why we have to add here an artificial variable with the coefficient as 1 unit. Now I have added this artificial variable in the second constraint. That is the reason I have taken the label for this artificial variable as A2. It's not compulsory that it's just a label. You can go ahead with any alphabet, with any A1, A2, A3, whatever you need it. But yes, this particular variable I have added in the second constraint. That's the reason I have taken it as the A2. Now, whenever we are adding the A2 or the artificial variable in the equality constraint or any greater than constraint, we have to add it with the minus of M A2. Now again, please do follow the previous session, that is wherein we have discussed about the big M method, introduce the big M method, because it's a maximization question we have done. So we have changed this minimization to a maximization. That's the reason we have to understand or we have to convert this as, or we have to add this A2 to the objective function with the minus M as the coefficient. Similarly, if you'll observe the third constraint, which is greater than or equals to constraint, we have to add, or we have to take it minus of 1 times S3, that is a surplus variable here, and again we have to reach to the initial basic feasible solution. That's the reason we have to add one more artificial variable in the third constraint, which is I have added here as A3. As we have added this as A3 just to reach the initial basic feasible solution, in the third constraint we have to add the same in the objective function with minus M as the coefficient of this. What we have done it for the A2, same we have to do it or repeat with the A3 in the objective constraint. And then the non-negativity constraint would be x1, x2, s1, s3, a2, a3 greater than or equals to 0. So as this is the third constraint, I have added the s3 and a3. But it is not compulsory. You can add any of the label like S1, S2, S3, S4. No constraint or no restriction on that. It is just a label. Therefore, an initial basic feasible solution is S1 is equals to 12. So if you will observe here from the first constraint, if I wanted to reach the initial basic feasible solution, we have to put x1, x2 and s3 is equals to 0. So why are we doing the s3 is equals to 0 in the present case? Otherwise, if the S3 will remain in the basis, that basis will have the RHS as negative, because this is minus S3 is equals to 10, so S3 will be giving us the value as minus of 10, but we don't want that. We always want the initial basic feasible solution for the simplex method, and this is what the penalty method or a big M method, which is almost same as that of the simplex with little addition of the artificial variable, and hence the penalty for those artificial variables in the objective function. So therefore S1 is 12, A2 is 10, A3 is 10 is obtained by putting x1, x2, S3 is equals to 0 in the respective 3 of the constraints. Now if we have the next page, or this purposely I have kept it here, and this particular table is blank, I have kept it, as we have already seen that S1, A2 and A3, they are the part of the basis or a basic variables, so we have to keep it here as, so S1, A2 and A3 would be the part of this particular first table. Now we wanted to fill this particular table using this particular constraints and this one. So we have got S1, the coefficient of S1 from the objective function, you can check it or locate it here, that is 0. This is what a CJ which we have written. My suggestion for you is please reach to the I button and reach to the simplex method, minimization type or a maximization type. You will understand the procedure, how this procedure has been followed in the particular channel, or I am following this here in this. A2, the coefficient is minus m in the objective function. Similarly, A3 is minus m. Now for the first constraint here, the first constraint would be this one. The coefficient of x1, x2, s1, s3, a2, a3, we have to put it here in the respective columns. So x1 is 2, 4, this is 1, this is 0, 0, 0, RHS is 12. Then a2, that is the second constraint, which would be 2, 2, 0, this is also 0, we have got this as 1, this is 0, and this is 10. The next constraint is the third one, that is 5, 2, this S1 is 0, S3 is minus of 1, A3 is 1, this is, sorry, A2 is 0 here, A3 is 1, and then it is 10. Then after going ahead with filling up this table, we have to calculate the Cj minus Zj, these values. Now we have already seen that how to calculate the Cj minus Zj values over here in this particular table. So we have just gone through for that particular thing. So Cj minus Zj, as we have done it. So let me just calculate one of the Cj minus Zj for this particular case. So we have got minus 5 here, that is Cj is minus 5 for this particular column, minus the multiplication of 0 into 2 plus 0 minus m into 2, that is minus 2m, minus m into 5, that is minus of 5m. That would gives us minus 5 plus, so this will become minus 7, minus becomes plus, so it would be 7m. So we have got the first is 7m minus 5 as the first element. Same thing you have to repeat it in the same. So we have what we have done and how we have done it here is this way. So this is the Cj minus Zj's we have calculated over here. So this is about the first column. Same way you have to calculate for the other columns. Please do pause the video here. Try to get the values on your own. Here with the time constraint, I am doing it directly as I have explained you here. Please follow the method what I have told you and just get the values. If at all you are not getting, pause the video, try to get the values. So these are the values which we are going to get, is Cj minus Zj in this particular case over here. Yeah, so just a minute, I'll just erase so it would be little clear for you all. Then we have to calculate the value of Z in the particular this one. So that would be this Cb into RHS. So 0 into 12 plus minus m into 10 plus minus m into 10, that would gives us the value of Z is equals to minus 20m. This is what is the value for this particular first initial iteration. Now we have to take the biggest value. So if you observe here, this capital M is the biggest number, It's a very big number, and that is why we have to always choose the number or take the number and compare the number in such a way. So if you observe 7m minus 5, 4m minus 3 and minus m. Minus m to we are not to consider, because we have to look at only the positive Cj minus Zj's here. And therefore, if you observe here, we have got this is the most positive element or most positive number here, that is 7m minus 5. That's the reason we have got this as the first, you can say, the pivot column, and based on this pivot column we have to calculate theta. So theta would be calculated as theta, or you can say the ratio is nothing but RHS upon what is the pivot, that is the first, that is this particular column elements of corresponding. So it would be x1 say for. So this is 12 by 2, that would gives us, so it's 12 by 2, sorry, it is 12 by 2, that is 6, then it is 10 by 2, that is 5, then it is 10 by 5, that is 2. So we have to look at here the least number, the smallest number. So you can easily check that 2 is the smallest number, and that is why the third row becomes the pivot row of this particular iteration, initial iteration. And in this way we can understand that this is the pivot row, and this becomes 5 becomes the pivot element. Now that means what? In the next iteration, x1 will come in place of a3. So a3 will leave the basis. So a3 will leave the basis because this is the outgoing variable, and this x1 is the incoming variable in the particular initial solution. Now that means this in the next iteration, in place of x3 we will be writing x1. As soon as, okay, let me go to the next page now. Now whenever you are going and going with the first, actually it's not a initial now, it becomes the first iteration now. In the first iteration, if you observe here, I have highlighted, or you can say fill up the values over here, fill up the color elements, so that I could not able to write down anything. That means as soon as the artificial variable is leaving the basis, we did not have to calculate any of the calculations further. That means we are not supposed to allow the artificial variable to get into the basis again. So that's the reason we need not to calculate anything under this A3 column forever till the end. Now this is the table what we have done it in the last page, and as we can easily check that in place of A3 we have to write down x1. The coefficient of x1 is minus 5. So please note the change here, 0, minus m and minus 5 over here. What is the change? Now everything we have to do it the same way what we have done in the previous, that is with I button. Please do follow the I button previously. Now we have to first write down, this is the 5 which is the pivot element. We have to have this element 1, so the dividing throughout this third row using 5, so that becomes here, so that becomes 1, because 5 by 5 1, then it is a 2 by 5, then it is 0, then minus 1 by 5, then it is 0, no need to calculate whatever it is, then the RHS becomes here in this case is 2. That means what? We have got this 5 element as 1. Now what is the next target? Next target is to make this 2 0, make this 2 0. Now suppose for example in the first row, R1 old, I have to fill up this R1 new, this particular row element. So what we are supposed to take the transformation as? That transformation is R1 old minus, this is a 2, and we have to make use of this 1 over here. So that is 2 times R3 new. That would be the transformation becomes over here. Let me explain you for this one element. So now it's a 2. So it's a 2 minus 2 times R3 new element is 1. So that becomes 0 over here. Similarly, this is a 4. This is a 4 over here. So it's a 4 minus 2 times, what is the element over here in this, which is 2 by 5. And that will gives us the value as 16 by 5. It becomes 4, yeah, it's a 20, so it's a 16 by 5 as the value for this particular second. Similarly, following the same transformation, we can get the values as 1, 2 by 5, 0, and then the RHS becomes here 8. How to calculate the RHS? Same transformation we have to make use of. That is 12 minus 2 times, over here we have got a 2. That means 12 minus 4, that is we got it here as 8. Now to get the second row, which is the R2 new for this table, we have to follow the transformation. That means we have to make this 2 0 using this 1 again. That is the same transformation will follow it here. That is R2 old minus 2 times R3 new. That becomes this second row with the same transformation what we have done it followed here the same way. We'll be getting this elements are 0, 6 by 5, 0, 2 by 5, 1, and then the RHS becomes here 6. Now the same way we have to calculate, after filling up this particular table, we have to calculate the same way all this Cj minus Zj's. Please follow the previous slide and you will be getting this Cj minus Zj for this particular case is 0. It is 6m by 5 minus 1. Then it is 0. It's 2m by 5 minus 1. It is 0. And then the Z for in this case becomes here minus 6m minus 6. You can check it with CB into RHS will give you the value of Z. Now as per this we have decided and which would be the biggest positive. So that will be the coefficient with the biggest coefficient of m. That will give you the second, or you can say the x2 will get in. That means the second column becomes the pivot column. And as soon as this becomes a pivot column, we can have, that means what we have decided that x2 is getting into the basis. Which variable needs to leave that basis, that we have to take it from the theta. So theta is nothing but 8 divided by 16 by 5. So this value you will be getting it as 5 by 2. Sorry, is that so? No. Yeah, it's a 5 by 2, that is 2.5. Then the next value will be getting 6 divided by 6 by 5. So that will be, it is nothing but 5. Then the next value is also 5. So if you will observe here, the least number or the small number is this. That means in the next iteration, S1 is leaving the basis. So this particular first row becomes the pivot row, and this is 16 by 5 becomes the pivot element. So 16 by 5 is the pivot element for the next iteration. Okay, moving ahead to the next one, I have already calculated, I have already kept this particular table, whatever we have got it in the previous step, so that we can refer it and make the changes in the table. Now what was the scenario? This is x2 is getting into the basis in place of s1. So that means s1, the place of s1, that is the first, is placed or replaced by x2, which is the coefficient is minus 3. Rest of the numbers or rest of this a2 and x1 will remain the same as it is. Now again this 16 by 5 is the pivot, so we have to multiply throughout by 5 by 16 or divide throughout the first row by 16 by 5. That becomes 0. This is 1. It's 1 by 3. It's 1 by 8. Then it's 0, 5 by 2. That is what is the first row, or you can say R1 new is going to get. Next task is to convert this 6 by 5 as 0 using this one element. So transformation, you have to choose the transformation for this R2 new as R2 old minus, what would be that? I don't want this 6 by 5 here, and instead of this I should have the 0. So that is 6 by 5 times this element, that is the element of R1 new. We are concentrating only on this particular number over here to get this as 0. To get this 0, we should have the transformation like this. And based on this transformation, we will be getting this as 0. Then we'll be getting the next is 0. This is minus 3 by 8. It's 1 by 4. It's 1, and then it's a 3 over here. Pause the video. Follow the transformation and try to get these rows over here. Similarly, this 2 by 5 needs to be 0 using this 1 again. The transformation becomes here as, okay, this would be the second, this would be the second transformation or second iteration. Then this particular third row, the same transformation we have to take it, R3 old minus 2 by 5 times R1 new. Based on this transformation, you can go ahead and you will get the values as 1, 0, minus 1 by 8, then it's minus 1 by 4, then it's 0, and then it's a 1 over here. Then again we have to go and calculate the Cj minus Zj's. You will be getting the Cj minus Zj's. Now if you observe, in every step Cj minus Zj will be 0 for these basis elements. So you can directly write down this x2, a2 and x1 as needs to be 0, and it will be automatically coming out to be 0. So that means x1 we have taken is 0. Similarly x2 is 0 because it's an element of the basis. Similarly a2 will have to be also 0. You can check it very well because of this one element or identity matrix element over here. We are going to get these values. So ultimately in this particular case we have to calculate only for these two values. Same thing is applicable for other variables also. So we have to just calculate the Cj minus Zj for this S1, which is coming out as minus 3m upon 8 plus 3 by 8, and then it is this particular value will be getting it as which is just a minute. So this is coming out as m by 4 minus 7 by 8 for this particular value, and therefore if you observe here, the coefficient of m is equals to minus over here in this S1. So in this particular iteration, this particular value or this S3 will get into the basis. So that means this row or this particular column would be the pivot column. Now to have this particular theta value would be 5 by 2 upon 1 by 8. That would be giving us the value as 40. Please do check it. And then the next value is 12, and next value is, because of this minus 4, this becomes nil, or we are not considering this particular value. And what would be the Z value over here? Z value is minus 3m minus 25 by 2 for this Z. Now out of these two values, which is the least one? Least is this 12. So we have this A2 element or A2 variable will be leaving the basis, and it will be going out of the basis, and that place, the place of A2 would be occupied by S3 in the next iteration. Now this is what is the previous table which we have got it in the last case. As you can see it over here, that A2, as soon as the A2 leaves the basis, we need not to calculate anything regarding to A2, and A3 we have already stopped it to calculate it. Now the particular variable, in place of this particular variable A2, we have got the variable as S3. Okay, we have got the variable as S3, and therefore we can just check this out. Because of this 1 by 4 is a pivot element, we have to calculate the same way what we have done it so far. Now I am directly putting the values over here the way which we have done it in the last case. So we have to take the values throughout this particular second. We have to divide by 1 by 4 throughout. So that will gives us the values as 0, 0, minus 3 by 2, 1, and this is 12. Next value is, I have to make this 1 by 8 as 0 using the transformation as which we have done it so far. That becomes 0, 1, 1 by 2, 0, and this is 1. Then to make this particular minus 1 by 4 as 0, using this particular one over here, just a minute, what was that? 1, 2, 3, 4, 2, 3, 4, no, not this one, we are doing this one, using this particular one. So we have to make it as this is 1, 0, minus 1 by 2, this is 0, and this becomes 4. Now you have to calculate everything Cj minus Zj. So if you observe, as I have told you, x2 0, s3 0, x1 0. So we have to just calculate the value for this s1, and here if you check this out, we will be getting the value as minus of 1. So that means what? We do not have any Cj minus Zj with a positive number, and that is the reason we have to stop at this place, and that means we have received here the optimal solution. What is the optimal solution in these cases? x1 is equals to 4, x2 is equals to 1, s3 we are not considering, but yes, this is also 12, we have got it, but it is not contributing anything in the objective function. And what is the value of z? You can check it with CB into RHS, that we have got it as minus of 23. So in this case, we have got this Cj minus Zj as positive, so we need to stop at this particular place. No need to calculate the theta for this particular values, and hence in one thing we can just take this out. This is what is the answer you are going to get it for this particular question. This is one table. You can just go ahead, as I have told you last time also, that as I have to explain you everything in detail, that's the reason I have taken one table at one iteration at a time. Otherwise, this is the way you have to express it directly in your exams also. You can go ahead and make a shortcut rather than to write down the tables and the variables every time, the CJs every time. So x1 is 4, x2 is 1, z max is minus 23. But we are not, we have just taken a help of maximization, but we are seeking here the z minimum value, which is 23. So x1 is 4, x2 is 1, z minimum is 23 in this particular case. And this is a self-observation slide wherein you have been given 1, 2, 3 equality. Because of the equality constraint, you have to introduce here a1, a2, a3 as the artificial variables, and you will be getting the big M method. You have to solve the big M method. Similarly, in the second question, the constraints are given to you as a greater than equals to constraint. That means you have to add here the surplus variable as well as the artificial variables, and you will be getting again through this. Please do follow and solve this particular question. If at all you have any query or you are not able to get it, please ask me. I will be trying to give you the solution for these questions as well. Thank you. Happy learning.